Today, I am going to teach you relationship between the primal and a dual solutions. What is the relationship? It means that if the problem is given directly, that part is called as a primal. So, in examination point of view, the question is given, calculate the maximum value of z is equal to so and so. Now we have to calculate only maximum only. But with the help of that maximum, how, how to calculate the minimum value also? If you want to use, if you want to calculate the minimum value, you have to use another some techniques. The techniques all are coming on one part. That part is called as a dual problem. Now, how to convert these equations, I will show you. Uh, I will show you. Please come to this point. So, now, so the relationship between so relationship between primal and dual solutions. Primal and dual solutions. So, if the problem is given like this, supposed to say that maximize z is equal to, supposed to say that 8x1 plus 4x2 subject to constraint 15x1 plus 4x2 less than or equal to 650, 25x1 plus 6x2 less than or equal to 840, x1 comma x2 greater than or equal to 0, x1 x1 to 0. So let's come to the point. So x1 comma x2 greater than or equal to 0. Now this is and this point yes, converted. So the problem is given like this. So this is called as a primal state. This point is called, this equation is called as a primal. So how to convert primal to, I mean to say that dual. Dual. Dual means only the thing is, in the primal point, all equations are contains x1 and x2. Now the dual means better to take another variables. So if the maximum case is given, then convert into opposite minimization. Z is equal to just the solution of these 650 and 840 equal to 650 y1 plus 840 y2. Next, subject to constraint. Subject to constraint. So take the first value. First value 15, 25. So here is a 15 y1 plus 25 y2 is the units of 8. It is corresponding to the value 8. So that first you write down 8. Now for what are the first inequality equation symbol? Less than or equal to. So better to go to greater than or equal to. Next go to the second equation. 4 and 6. So that 4y1 plus 6y2. Then opposite value is a 4. So that write down 4. The second inequality equation less than or equal to, better to go to greater than or equal to. So y1 comma y2 greater than or equal to 0. So this is the, after that calculation is the second thing. Now today just we learn about something, how to convert the inequality equations of a primal to dual only. Suppose another example, suppose say z is equal to, suppose to say, so z is equal to, I mean to say that maximize z is equal to 4x1 plus 2x2 plus 5x3. Now come to this point of this another. So that is subject to constraint. So 3x1 plus 4x2 plus 6x3 less than or equal to 10. So x1 plus 5x2 plus 7x3 less than or equal to 12. 2x1 plus 6x2 plus 2x3 less than or equal to 13. So x1 comma x2 comma x3 greater than or equal to 0. Now use the dual method. First, before applying the methodology, first you convert primal to dual. If the question is given maximization, opposite symbol is minimization. So this is the primal. So this point is called as a primal. First you write like this. So that is take this and erase it, erase it, erase it. Erase it. Now come to this point. Now come to this. Here is the minimize. So this is called as a, this point is called as a primal. First you write down primal. Okay. Now first you write down next dual subject. So maximization is given. Write down minimization. Minimization. Z is equal to. Here, after inequality symbols 10, 12, 13, it convert into objective function values. 10y1 plus 12y2 plus 13y3. Next, subject to constraint. Take the first column values, column coefficients 3, 1, 2. So that 3y1 plus 1y2 plus 2y3. So what are the first column corresponding value? 4 in objective function. So first we write down 4 here. See the first symbol, first inequality symbol is given, first equation. So opposite symbol write down greater than or equal to. Go to the second column values 4, 5, 6 coefficients. So 4y1 plus 5y2 plus 6y3. The second equation opposite to 2. So that write down, first we write down 2. What are the second equation inequality? Less than or equal to. Better to go to greater than or equal to. Next third one 6, 7, 2. So 6y1 plus 7y2 plus 2y3. What are the third value? 5. So that write down 5. So that greater than or equal to. Next to y1 comma y2 comma y3 greater than or equal to 0. Now the first conversion is over. So this is dual. Once if you convert the dual, solvation is the second criteria. Forget about the how to solve the problem. Just I will explain the point to point. Only the thing is today just I am going to conversion of the given equation. Suppose the question is given like this one. So minimization, minimize, next minimize. Z is equal to, supposed to say that 2x1 plus 4x2 plus 8x3. Next, subject to constraint. So that x1 plus 3x2 and plus 5x3. The minimization means always greater than or equal to. Supposed to say that 6. Next to 2x1 plus 4x2 plus 6x3 greater than or equal to 8. And the next one 3x1 plus 3x2 plus 7x3 greater than or equal to 9. The problem is given like this. So x1, x2, x3. Calculate maximum minimum value with the help of dual simplex method. Or in examination point of view, the problem is given like this. Find the value of variables x1, x2 values by the dual simplex method. Now the question, this is called as a primal process. This is called as a primal. Understand? Now come to the point of the dual. So how to convert the dual? Just setting is a dual. First you write down dual here like this, dual. So if the question is given minimization, write down the maximization. That the maximization. What are the maximization? Z is equal to. Better to change the variables. Variables means 6, 8, 9. It is converted into 6y1 plus 8y2 plus 9y3. Next, subject to constraint. Take the first equation, 1, 2, 3. So 1y1 plus 2y2 plus 3y3. So what are the first value here? First column corresponding to 2. Write down to first, write down to the equation of the first greater than or is given. Better to write down less than or equal to. Next, go to the second column value, 3, 4, 3. So 3y1 plus 4y2 plus 3y3. What are the second column corresponding to 4? Write down here 4. The second symbol is given greater than or equal to. Better to write down less than or equal to. Go to the third equation, 5, 6, 7. So 5y1, so plus 6y2 plus 7y3. So less than or equal to 8. Next, y1 comma y2 comma y3 greater than or equal to 0. So the point is now how to convert the equations I of primal to dual. So in examination point, now I'm going to solve simplex method of one problem with the help of a dual. Now come to this point. Now I'm going to two variable problems, dual simplex method. Dual simplex method. So take this one problem. Find, problem is given like this. Find the dual of minimize z is equal to x1 plus x2 subject to constraint 2x1 plus x2 greater than or equal to 2 minus x1 minus x2 greater than or equal to 1. So x1 comma x2 greater than or equal to 0. Greater than or equal to 0. So this is it. So now the question is given dual. This is a very important point. Calculate the using the simplex method by dual only. Now the problem is given. This set is called as a primal. Better to convert to dual. The point is the next point is how to convert the value dual. So dual means opposite values. If the question is given minimization, you have to write down maximize. Maximization. Z is equal to take these two values after. So 2y1 plus 1y2. Now subject to constraints. So take the first column values 2 and minus 1. So here is a 2y1 minus y2. The corresponding value in the minimization objective function 1. So first you write down 1. If the first symbol is greater than or equal to, write down less than or equal to. Go to the second value 1 and 1. 1y1 minus 1y2. The second column value is 1. You write down 1. So this is the greater than to less than convert. So y1 comma y2 greater than or equal to 0. That's all. So primal to dual, already you know how to convert the equation. Now forget about the given question. Now this is your main question. Max dual is the main question. Now come to this point. So how to convert the equation less than according to our basic concept. The problem is given less than or equal to and greater than or equal to. Less than means introduce yes, greater than means a and a yes. So conversion this one. So that is equal to 2y1 minus y2 plus 1s1 equal to 1. Next go to this 1y1 minus 1y2 plus 1s2 equal to 1 because inequality equations to equal equations. So this is equal and y1 comma y2 s1 S2 greater than or equal to 0. Finish. Now how to convert the objective function of the maximization? This 2y1 plus 1y2 plus 0s1 plus 0s2. Finish. Now conversion is over. Next, solve. And now we are going to solve the problem. Better to introduce these variables to the simplex table. Now how to draw the simplex table here? So that is called simplex table. Simplex table. So same principle of a previous problem. So first we write down Ci. BV means basic variable. SV means solution value. X1, X2, S1, S2. The last column is minimum ratio. Minimum ratio. Okay. So minimum ratio. Now take this column. Please draw this column. It is one column. This is another column. It is another column. It is another column, like this. So this is a fundamental point. Already you know, because already we solved the number of problems. Now take this one. Please draw this top row values like this, and like this. Okay, this is a Cj. Understand? Cj means top values, objective functions. 2. Okay, no, sorry. Instead of x1, introduce y1 only, sorry. So come to this point, better to remove this part and take, because we are in the y1 only. So this y, that's all. That's all. Now come to this point. Here is a y1, y2, not x1, x2, because dual. So 2, 1, 0 and 0. Now come to this point. Please introduce, because coefficients on the first equations 2, same procedure. 2 minus 1, 1, 0. Second one, 1 minus 1, 0, 1. What are the solution values after? 1, 1. Here is unit matrix is available here only 1, 0, 0, 1. What are the corresponding value of 1? 0 S1, 0 S1, 0 S2. Okay. Now, so after that, please draw the horizontal line. Same procedure. Please continue the lines here. Continue the lines here. Like this. Like. The next value is Zj. Understand? Zj value. How to calculate the Zj value? Zj means, what is the basic formula for Zj? Please refer to the previous problem. Zj is nothing but sigma Ci into yi, because here the problems contains y. In previous problems, x. So 0 into 2 plus 0 into 1, like this. 0 sigma means addition. 0 into 2 plus 0 into 1, that is equal to 0. Please write down 0 here. Go to second, for y2 column value. 0 into minus 1 plus 0 into minus 1, 0. Go to this, 0 into 1 plus 0 into 0, 0. Same 0. Once Zj is over, next please draw this horizontal line. Next go to, what are the next procedure? Cj minus Zj. So Cj minus Zj. What are the Cj here? Cj values are available. First row value, top row value 2. 2 minus 0, 2. 1 minus 0, 1. 0 minus 0, 0, 0. So that out of values which are present in the Cj minus Zj, all are positive. It means select the maximum positive value, that is called as a key column. This is called as a key column. See, in this one, what is this? This is a key column and a key row. This is called as a key column and this is a key row. Key row. And this point is called as a key element. Key element. Understand? Now come to the minimum. How to calculate the minimum ratio values? SV by Kc. Solution value by key column. Solution value is 1 divided by 2. 1 divided by 2, it means 0.5. 1 divided by 1. So that is equal to 1 only. So out of these two, which is the minimum positive value? This is the minimum positive value. So for key column, select the maximum positive value. For key row, select the minimum positive value. So minimum positive value means this one, and so yes, come to this point. So this is the key row. Please write down the key row. Key row is over. Next key row and key column, key row is over. Next, after that, go to the first iteration. So after that, better to introduce and this. So key row and key column indicates that we have to change the values in key row and key column first. It means 0 S1 and key column here is there, intersection. So that first you remove 0 S1, write down 2Y1. So that 2Y1, this is called as 0 S2 as it is because there is no key row here. Next, come to this. Next, what is the next? Take a key element value. Take a key element value. Divide it to all elements which are present in the key row. The first point, take a key element. These two, divide it to all elements which are present in the key row. It means that 1 by 2, 1 minus 1 by 2, 1 by 2, 0. Understand? So 1 is there. The key row, column values all are equal to 0. Remaining values are 0 because it represents unit matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So this is the way called as. So this is 0 over. The next, how to calculate the remaining value of the second row values here? Simple thing, our formula. What is the basic logic formula? A minus B into C by D. Or if you want to refer any textbooks, in the textbook they are using the methodology, different types of methodology, that is a row operation. Gauss-Jordan method. It's okay. That method is also correct. Better to use our logic method A. What is A? These are the assumption process. Let this as A. And the top is a B. A straight key column C. And this has the D. D is a fixed. That is a key element. What are the basic formula A? 1 minus 1 into 1 by 2. Take 2 as LCM. 2 minus 1, 1 by 2. Write down 1 by 2. Go to this over. This minus 1 A. This as A. The top one is a B. Key row. It always goes to key column C and D. So minus 1. What is the basic formula? Minus 1. So that is minus 1 into B plus 1 into 1 by 2. Take this 2 minus 2 plus 1 minus 1 by 2 minus 1 by 2. Okay. Next 0 minus 1 into this one. So minus 1 by 2 using our formula. 1 minus 0 into 1 by 2, that is equal to 1. Finish. The next value is ZJ. Same thing. What are the ZJ formula? ZJ. So ZJ means this is the ZJ values. Understand? So ZJ means using formula. ZJ is nothing but sigma C into Y. So it means that 2 into 1 plus 0 into 0. 2 into 1 plus 0 into 0. That is called as a 2. 2 into minus 1 by 2 plus 0 into 1 minus 1 by 2 minus 1. And 2 into 1 by 2 plus 0 into minus 1 by 2, 1. That's 2 into 0 plus 0 into 1. That is called as a 0. Next go to Cj minus Zj. Same thing. Cj minus Zj. What are the Cj value here? The Cj is given in the top row. 2, listen, this is 2. 2 minus 2, 0. 1, okay, 1 minus of minus 2, and 0 minus 1 minus 1, and 0 minus 0, that is called as a 0. 0 minus 0, 0. So for key row, select for key column, select a maximum positive value for key column. Now, minimum ratio. What is the basic formula minimum ratio? SV by Kc for the first iteration. SV 1 by 2 minus 1 by 2. 1 by 2 divided by minus 1 by 2, that is equal to minus 1. 1 by 2 minus 1 by 2, that is also minus 1. And please, the important point, particularly in this problem, in a minimum ratio, if we have two negative values, immediately stop the problems, because it is an unbounded solution. What is the main definition of the minimum ratio? The main definition of the minimum ratio, better to select the minimum positive value. Here is a minimum positive value. If you have any minimum positive value, then select a minimum positive value for a key row. Then you go to the next operation, next iteration, operation or iterations, and etc. But there is no all are two negative values, so they immediately stop the problem. It means that it is very difficult to find out the values of minimization or maximization or dual simplex method. So write down the statement, simple statement. So what are the statement here? So that is since it is difficult it is it is difficult to decide departing variables as minimum ratio have negative values the given LP full stop, the given linear programming problem has got unbounded solution. Finish. Okay, why? How can you say that the problem is unbounded solution? Unbounded solution means because in the minimum ratio, these two negative, this and negative, it means it is a very difficult to find out the value of key row value. Key row means always select the minimum positive value. Both are negative, immediately stop the problem, write down the statement what are the given problem. So this is a problem which are given, this. So dual to, please come to the original question, find the dual of. The question is given minimization, then you convert into opposite of the maximization. In a minimization, the variables contains x variables, better to take y variables. So minimization means these the values, two variables, it means 2, 1 is converted into maximization function, 2y1 plus 1y2. The next you go to the first equation, 2y1 plus 1y2 minus 1y2, the first corresponding minimization value, so 1. If it is equation is greater than or equal to, convert into less than or equal, like this. So after that convert, because it is a inequality equations, then you convert equal equations. Equal equation, better to our ideas, our logic point. If the equations contains less than or equal to, better to introduce slack variables. If the equation contains greater than or equal to, better to introduce artificial and a slack variable. So like this. After that, take all elements and enter into the simplex table. Already you know the simplex table is a constant Cj, Ci, where I and j, ith column jth row. That's all. So next basic variable solution values. Don't write x1 x2 because the question is given dual, so that the simplex table contains y variables. It means this table according to second case dual, you have to prepare the simplex table with the help of y1 y2 values only. Forget about the x1 x2. If you take x1 x2, that is general simplex method. General simplex method is not suitable here. Already the examination point of view, he already mentioned the dual, so dual values only. Now apply our conditions according to the key column and key row, Cj, Zj, next Cj minus Zj values and etc. And for the first iterations like this, for the second first key column is a maximum positive values in Cj minus Zj row values. So these two, so make, I mean to say that key column. Go to the key row. For the key row values, means if you want to find out the key row values, you have to first of all calculate the minimum ratio value. Minimum ratio value is SV by Kc. What are the SV? See, 1 by 2 here. Key column means of minus 1 by 2. Write down minus 1 like this, minus 1. If both are negative values, immediately stop the problem. Don't continue, because negative minimum ratio, if anyone is a positive out of these two, if anyone is a positive, so I mean to say that take that row for the key row. Once if you'll get a key column, key row, again apply same A, our logic point A minus B into C by D like this only. So immediately both are negative, so that so since it is a difficulty to write down the decide the dependent variables, minimum ratio have negative values, the given LP has got unbounded. This is a very important. Unbounded solution means no solution. That's all. No maximization and no minimization. So now the problem is completed. Next, go to another problem. Another problem. So